Hello, we are going to show you how to solve exercise 21. As you can see in this exercise, there is a double integral with the order dy dx, and we have to match a specific sketch with this double integral. Until now, we only have seen a single integral, which can be used to compute the area under a certain function from a certain interval, so let's take a to b. And if you put this in an integral, you get a to b from your function dx. But in this case, we have a double integral. And it's important to know that you always compute the double integral from the inside to the outside, but that you read an integral from the outside to the inside. This can be done in two certain ways. The first way is with vertical cross sections. So you take a certain interval on the x-axis, between 0 and 1 in this case, and then you choose a certain point on that interval. So let's take this point. Then you draw a line perpendicular to the axis you chose, and then you are going to see where it enters your region and where it leaves your region, and that is going to be your lower bound and upper bound. So first we are going to put 0 to 1 at the beginning. So that's your first step, take an interval on one of the axes, and that was on the x-axis. And then we are going to fill in our lower bound and upper bound. So our lower bound is 1 minus x, and the upper bound is the square root of 1 minus x squared. If you want to compute the area, so this is going to be dy. If you want to compute an area, this is just going to be a1. But if you are talking about a volume, this can also be a surface in three-dimensional space. So this is going to be something like fxy. But you can also compute this region with horizontal cross-section. And then you take a certain interval on the y-axis. So then you get the dy at the end, and you take the interval 0 to 1. And then you take a certain point on your interval, and you are going to see where it enters your region and where it leaves your region. Make sure if you take horizontal cross sections, your formulas are in x is something with y. And now it enters our region at 1 minus y, and it leaves our region at the square root of 1 minus y squared. If you only want to take the area, we're just going to fill in a1. Now back to our problem. We have something with a formula inside here, but that only says something about the height or something about the volume, and not something about the region of integration. So that we can just leave out. We just said that we're going to read it from the outside to the inside. So we take a certain interval on the x-axis between 0 and 1. All the answers take an interval to 0 and 1, so we can't cross 1 out yet. But now we have our y boundaries. So if we take a certain interval on the x-axis and the y, you have the square root of x, which is something like this. And we have the interval 0 to 1. And if we take a certain point on that, we're going to draw a line. and it enters our region at y is the square root of x. So this is where the region begins. And it leaves the region at y is 1, which is this line. So it leaves the region at this point. So this is the piece we want to compute. If we take another point, we enter the region here and we leave the region here. So this is our piece we compute. And if you do it over and over, you can see that this region is the one you can calculate with this integral, and that matches with answer A. So the correct answer is A.